Okay, welcome back to the math packet for our second day. Where we left off was on this page here, which corresponds to a page in your math packet, only you don't have all the answers written in. Significant figures worksheet number 1. We were down below the tables, starting with part A on that page. And so we'll just continue on from there with some more examples that you can try. I'll let you pause. You can always pause the video and try a calculation before I actually show you the solution to it. That is actually a very good idea, and that's a good way to learn how to do these things, is to try it yourself before you actually see the solution. And yesterday we went over the idea, of significant figures and how to determine the number of significant figures in a number, and also how to do calculations involving significant figures. So remember, first of all, that the whole idea behind significant figures is to evaluate the accuracy with which we know certain measurements or numbers, and to avoid giving the impression that we know a number or a measurement more accurately than we really do. So generally, the more significant figures we express, the more accurately we are implying that we know the number. And the fewer significant figures there are, the less accurately we know the number. So basically what we're doing here at the bottom of this page is trying to do calculations in significant figures. Now, if we take 6.05 meters times 4.5 meters, the answer, first of all, is going to be in units of square meters, because remember, units act just like numbers when you multiply or divide them. So meters times meters would be meters to the second power. And if you take your calculator and take 6.05 times 4.5, what you get is 27.225. Now, we were sort of alerted to the fact that we need to watch significant figures in these calculations. And so we need to evaluate we need to find how many significant figures we're allowed to use in the answer. And for that, we need to look at the number of significant figures in the two numbers that went in to calculating this answer. First of all, we have 6.05. We have a 6 and a 5, and they definitely count as significant figures, because as we said before, all non-zero digits always count as significant figures. The zeros are the problem here. Sometimes zeros count, sometimes they don't. This 0 is between two other numbers that are not zeros, and that means that the 0 counts also. So that's 3 significant figures for that number. This number, though, doesn't have any zeros, so there's no doubt about it. That means that number only has 2 significant figures. In calculations, you'll always go with the number that has fewer significant figures, and so that means our answer should only have 2 significant figures. So we have to round off this number 27.225 so that it has 2 significant figures. That means the 2 and the 7 can stay, but everything else has to go. But remember, when you round off a number, you have to look at the first number you're dropping, which is a 2 in this case, and if that number is less than 5, which it is, then you don't have to make any changes to the numbers you're keeping. If the first number to be dropped is 5 or greater, then you have to increase the last number you're keeping by 1. And we'll see examples like that, but this isn't one of them. So 27.225 to 2 significant figures is 27 square meters. Okay, so that's the first one. Down below, we have another one, which is 32.9 meters plus 1.4 meters. Now remember, when you add numbers with units, the units have to be the same, and that means the units of your answers will be the same. So 32.9 plus 1.4 comes out to 34.3. Remember, in addition and subtraction, though, It's not the total number of significant figures we're concerned about. It's the number of decimal spaces. So this number here has 1 digit past the decimal point. This number here also has 1 digit past the decimal point. So the answer should have 1 decimal space. And what do you know? It does. So 34.3 actually is the answer to the correct number of significant places. Okay, in division, like for instance 340 meters over 12 seconds, what we're doing here is calculating a speed or a velocity, which is distance divided by time. So this object, whatever it is, covered 340 meters in a time of 12 seconds. And the units will end up being meters per second. And when you take 340 divided by 12, you get 28.3 repeating. Okay, so we're going to have to evaluate the number of significant figures. 340, you might be tempted to say 3 significant figures, but remember about the zeros. Zeros at the end of a number do not count if there's no decimal point. And in fact, there is no decimal point in this number. So that's 2 significant figures, the 3 and the 4, not the 0. The number on the bottom is 12. That's obviously 2 significant figures also. So the answer should have 2 significant figures. That means that the 28 can stay, but everything after that has to go. Again, the first number you're dropping is a 3. That's less than 5, so you don't have to make any changes to the numbers that remain. So 28 meters per second would be the answer to the correct number of significant figures. Okay, on the following page, we have significant figures worksheet number 2. And this is the first part of that is about actually calculating the number of significant figures in given numbers. And we have 0.0490 seconds. And the number of significant figures here, you might want to work on that for a moment by pausing the video. But anyway, I'm going to go in and show you. Obviously, the 4 and the 9 count. The zeros are the question. Zeros at the beginning of a number are never significant, no matter what, never significant. So you don't count those. But what about the one at the end? Well, zeros at the end of a number, remember, they are significant if there is a decimal point in the number. And there is. It's way up here at the front, but that's a decimal point, so that means that the 0 at the end counts. So that would be 3 significant figures for that number. Okay, 2 is 5,025. Obviously, the 5 and the 2 and the 5 count. The real question is about the 0. This 0 is between numbers that are not zeros, and so that means that that counts also. So that's 4 significant figures. As an aside, I just wanted to emphasize that when we say a 0 that's between numbers that are not zeros, it doesn't have to have a non-zero number immediately on either side of it. This number here actually has 5 significant figures. Obviously, the 5 and the 2 and the 5 count as significant figures, but both of these zeros are between numbers that are not zeros. So both of those zeros count, even though one of them has a 0 immediately on either side of it. So I added that one in just to illustrate the point. Next, we have number 3 is 0.000068 meters. This is pretty easy, actually. 6 and the 8 count. Zeros at the beginning of a number never count. These zeros at the beginning of the number are just there to locate the decimal point. Okay, so this is 2 significant figures. Okay, 50.0 is how many? Well, the 5 obviously counts, but what about the zeros? Well, again, there's a decimal point there, so the zeros at the end of the number do count, and that would be 3 significant figures. Next, we have the number 50 seconds, and in this case, there's no decimal point, so it's only the 5 that counts. The 0 doesn't count. So that's only 1 significant figure. And down below here, we have some other calculations. We have number 6. This is under part B. We're supposed to do the calculation and first say the number of significant figures that should be in the answer. Okay, so let's see. Our first number is 4.50 centimeters times 5.9 centimeters, and that's equal to, and we're supposed to predict the number of significant figures in the answer before we actually give the answer. So let's see here, you've got the 4 and the 5 that count, and in this case, the 0 at the end counts also because there's a decimal point. So that's 3 significant figures. 5.9 obviously is only 2 significant figures. You go with the smaller number of significant figures, so the answer should have 2 significant figures. If you actually put this in your calculator, it's going to come out as 26.55 square centimeters. This is because, as I've said before, calculators don't understand significant figures. They assume that every number that you enter is followed after the decimal point by nothing but zeros. So it'll give you as many digits as it possibly can. This is obviously 4 significant figures, and so we need to convert it to 2 significant figures. That means the first 2 digits can stay, but everything after that has to go. Notice in this case that the first number we're dropping is a 5. The rule is that if the first number you're dropping is 5 or greater, then the last number you're keeping has to go up by 1. So 26.55 rounds off to 27 square centimeters. And that would be the proper answer. Okay, the second number 6. This is a funny thing about Microsoft Word. It insists on numbering things automatically, but it keeps doing stuff like this, giving you 2 6s in a row. So the calculation is 3.2 meters over 0.020 seconds. And that would be equal to, and we'll see in a moment what that's equal to. First of all, significant figures. The number on top obviously has 2 significant figures because there are no zeros in it. The number on the bottom, let's see, zeros at the beginning of a number don't count. Zeros at the end of a number count if there's a decimal point, which there is in this case. So that last 0 counts, as does the 2. And that's 2 significant figures. So I guess the answer is probably going to have 2 significant figures. If you put 3.2 divided by 0.02, you get 160. And that's meters per second. That actually is the correct number because as long as you don't use a decimal point, that is 2 significant figures. Because remember, zeros at the end of a number don't count if there's no decimal point. So you got to be careful, though. If you put a decimal point after that 0, it's 3 significant figures, and it's not correct. All right, so in number 7, we have 12.9 centimeters plus 2.0 centimeters plus 5.06 centimeters. Now, remember, for addition and subtraction, it's not total number of significant figures we're concerned about, it's the number of decimal spaces. So the first number obviously only has 1 decimal space. The second number has 1 decimal space. The third number has 2 decimal spaces. So you go with the fewest number of decimal spaces, which would be 1, which is a tie between the first 2 numbers. And when we add this number together in our calculator, we actually come up with 19.96 centimeters. That's actually 2 decimal spaces. So we have to convert the number to 1 decimal space, meaning that we have to drop the 9/6. Now the first number we're dropping is a 9, which means that the last number before that has to go up by 1. But the last number before that is 9, which means if that goes up by 1, it becomes 10, which adds to the 1. So 19, when you round it up by 1, comes out to be 20. So that number, to the proper number of significant figures, is 20. Okay, on the other side of the sheet, or on the next page, depending on whether you've got, well, it'd be the next page, actually, if you're looking at the PDF. The calculation is 590 meters minus 5.0 meters. This is subtraction, so again, we're following the rules for addition and subtraction. So here we've got no decimal spaces, and here we have 1 decimal space. You go with the smaller number, so that's 0. And if you have 590 minus 5.0, and you do it on the calculator, you actually get the correct number of significant figures out of this, which is 585 meters. Because that number doesn't have any decimal spaces. Okay. The next exercise here is number 9 in part C, and it involves measuring the length and width of a piece of paper in centimeters. Okay, the length of a piece of paper, if you do this with a metric ruler that's marked off in centimeters and millimeters, you should come out with 27.94 centimeters for the length of the paper. I'm assuming that this is a standard US size 8.5 by 11 inch piece of paper, because 11 inches corresponds to 27.94 centimeters. On the metric ruler, it's marked off in centimeters, which are these numbers here, the 27, and millimeters. A millimeter is 1/10 of a centimeter, so the 0.9 would be the smallest markings on the ruler. And then you should estimate how far the piece of paper comes between the smallest markings. And it should appear as if the paper comes about a little less than halfway between the 0.9 and the next line. Okay, so that would be 0.94. We assume, of course, that that last digit, because it's estimated, we assume that that last digit is accurate to plus or minus 1. Okay, so you may not agree with that number exactly, but that's why this number is would be 27.94 plus or minus 0.01. So that means that this number would actually represent a range anywhere from 27.93 to 27.95 centimeters. Okay, so that's that would be the length. The width of a standard US piece of paper is 8.5 inches, and 8.5 inches corresponds to 21.59 centimeters. So again, the 21 would be the markings on the centimeters. The 0.5 would be the smallest marking on the ruler, the millimeters or tenths of a centimeter, and it should go almost to 21.6 exactly, but not quite. And so I would end up reading that as 21.59. But again, that's plus or minus 0.01 since we estimate that last digit. And that means that the range could be anywhere from 21.58 to 21.60 in centimeters. And that allows for some disagreement on how to interpret the numbers on the ruler. The area of the sheet of paper would be length times width. That's 27.94 centimeters times 21.59 centimeters, which comes out to, let's see what it comes out to fully when you put it in the calculator. 27.94 times 21.59 gives you 603.2246 square centimeters. Now, in significant figures, that's way overboard. This number here, 2794, has 4 significant figures. 21.59 also has 4 significant figures. That means the answer should have 4 significant figures. So we can keep the 6 and the 0 and the 3 and the 2, but everything else has to go. Notice the first number we're dropping is a 2, so that means that the number before it can stay the same. It's 603.2 cubic, or square centimeters to 4 significant figures. Okay, and next it asks you to find the volume of your textbook, measuring in, say, where are we at here? In centimeters. I was using my older edition of the textbook, and it's a little beaten up, so it might come out a little different from yours. Also, particularly because my older edition of the textbook is a fully bound version, and the version they're selling now is a loose leaf, so that might come out a little differently. But what I got was 27.46 centimeters by 22.86 centimeters by 2.54 centimeters. And your numbers may vary a little bit because you've got a different edition of the book. There may even be a different number of pages, actually. And when you combine these numbers together to get the volume, you get 27.46 times 22.86 times 2.54. That gives you 1,594.44824. A lot of 4s in that number. And that's in cubic centimeters. Obviously, that's way overboard in terms of significant figures. Okay, and remember, that is a 4. For the significant figures, we have to look at the numbers that went into this result and see how many significant figures they have. 27.46 is obviously 4 significant figures. 22.86 is obviously also 4 significant figures, but 2.54 is 3 significant figures. And we go with the smallest number of significant figures, so 3 it is. So 1594 1594.44 blah 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 becomes 1590. Now, everything from this first 4 onward has to go. The first number we're dropping is a 4. That doesn't affect the numbers before it, so the 159 can stay the same. But also remember, whenever you drop a number before the decimal point, you have to replace it with a 0 in order to maintain the magnitude of the number. Okay, so I'll write that down because that's important to remember. So it's 1,590 cubic centimeters. No decimal point though. Remember, this number is 3 significant figures because the 0 at the end doesn't count as long as there's no decimal point. But if you put a decimal point in, then the 0 at the end does count and it becomes 4 significant figures. Okay, next we can move on to the page marked More Significant Figures Practice. And it's the one that starts with the, according to the rules, all of these measurements have 3 significant figures. Make sure that you understand why. If not, please ask me. And you can do that. I'm going to show you why, though, in a moment. So we have a number that's just putting out too much ink. First number, 0.000480 seconds. And we want to know how many significant figures that is. Well, remember, zeros at the beginning of a number never count towards significant figures. Zeros at the end of a number do count if there's a decimal point anywhere in the number, which there is. So that 0 counts, and the 4 and the 8 count, so that's 3 significant figures. Okay, also number 1, 3,840 meters. That's 3 significant figures. Obviously, the 3, 8, and 4 count, but remember, the 0 at the end doesn't count if there's no decimal point. So that's 3 significant figures. The next number, 28.0 seconds. And the 2 and the 8 obviously count. The 0 also counts because there is a decimal point in the number. So that's 3 significant figures. Okay, according to the clock, we've been going just about 30 minutes, so I'm going to stop this here, and then we'll go on to part B. Okay, see you in a moment.